Hi guys, today I want to show you guys how to implement the least recently used cache in LeetCode in C++. I'll be showing you guys how to use what I consider one of the fastest methods and how to implement it. So yeah, let's do this. So they want us to implement a least recently used cache that supports two methods. Get, which is the first method, should return -1 when the key does not exist in the cache. Else, it should return the value of the key. Set, on the other hand, should set the value of the key to the new value if it exists, or it inserts the value pair. So the key value will be inserted into the cache if it's not present. When the cache reaches full capacity, it should kick out the least recently used item before inserting. So yeah, pretty straightforward directions, so let's get to it. And I'll be using Visual Studio as my IDE just because it provides bug detection before I compile, which is pretty helpful. So, as we can already see, we'll need two data structures for this. One to keep track of the least recently used items, and one to act as our access for the key and values. So we're going to use a order map, which is C++'s equivalent of hash table, and we're actually going to use the first parameter, which is an int, because that's a type. That's what our key type is. And we're actually not going to use the int as our second parameter for value, even though it's kind of like, key value, both int, we should have that, but we're going to do something different. We're going to call it list. We're going to do a pair, which is going to contain the value, and a list iterator. And we'll see why later we do this. Call cache, and we should also have a list to store the list of keys, and then we should also have a capacity to store our capacity. So the order map is going to have key, value, and the key iterator. While on the other hand, the list will just be a list of keys. The first element is the most recently used, and the last is the least recently used. Oh, and we should also include the order map library. Alright, so we're going to initialize the capacity. Simple enough. So for get, there are two scenarios that we need to consider: if the key exists or if it doesn't exist. So if the key doesn't exist, it's pretty simple. We just return -1. Else, if the key does exist, we'll return the value. So I'm going to use auto cache find key, try to find the matching value. And if the item is not found, which means that it's going to be equal to cache end, then we're going to return -1. Auto is just a lazy way for me to not have to write order map iterator. So just if some of you guys didn't know. So if the key exists, we need to return the value, and the value is in. So we need to dereference this iterator to this order map, and we're going to access the second part of the value part of the map, which is the second. And to get the actual value, I know it's kind of confusing, but to get this is our actual value, remember? So we need to do first. Oh, but one thing we should know, One thing we should know that since getting the item is considered accessing it, which is also quote-unquote using it, we need to update our LRU. And for that, I'm actually going to create a helper method. called use. And what it's going to take in as a parameter is going to take in this order map iterator. I'm going to give a reference. Oops, sorry. And here's what I'm going to do. So remember how we said that the first thing is the most recently used? Well, the reason why we use a list as opposed to something like a vector is because a vector, when you insert in the front, is not at least I think it's not an O of 1 operation, because once you insert in the front, you need to make sure there's space, or else you have to, resize, and you also have to shift all the elements down by 1. So it's not the most efficient way to do it, while as a list has O of 1 of inserting and removal from front and back, and anywhere inside the structure itself, as long as you have an iterator to that node, I guess what you call it. So hope that explains why we are using a list. So in this example, how we are doing it is, say you have a list like this: 1 connected 2 connected 3, and 2 used to be the item before, or the key before we accessed it. So now we need to somehow get this, because because 2 is most recently used because it has some access. So the way I'm going to do it is I'm going to delete this, so these two get connected, and then I'm going to push a copy of it back in front, and that's just going to take O of 1 constant time. So enough, we're going to delete that, right, because it's going to dereference to this, and it's going to delete this, which is an iterator pointing as an element in here, and then we're going to push it to the front. The new key, right, because the key is going to be here. Wait, what? Oh, not erase. What the heck am I doing? Push front. And another thing we need to do is, once we took out this guy, right, this is the old key iterator. We need to update this with the new key iterator to the most recently used key. But since we already pushed it to the front, we can just change this to the front of the list. So what I'm going to do is cache. Whoops, sorry. Right, actually. No, not cache. Take the iterator, dereference to second, which is going to be this iterator here. I'm going to set it equal to the first thing in the list. That should be it for how we should update. So before we return, we should update this iterator. Nice. And now that should be it for our get. Now for set, we have a bit more trouble. If the key exists, just set the value, right? So we do the same thing as we did before. Use the same naming scheme. Find key if item exists, which means that's not going to hit the end. We're gonna hit update. So actually first, we're gonna update it first. So use item, and then we're gonna change cache. So this means that we're setting the value of the key to something else. So remember, the value is a pair. Instead of writing standard pair blah 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 blah, this is a faster way for me to construct a pair. So first it takes in the value, right, and then takes the key iterator. And the key iterator, remember, we know that it's the most recently used, and in used we pushed it to the front, so it just be the beginning of the list. And we can technically return from here because we're done. That's all we need to do if the key exists. Now, if the key doesn't exist, we do several things. Check the capacity, and then use the and then check the capacity, and then we should update. No, actually, I'm sorry, not update, but we should insert new key value. So if the key doesn't exist, we need to check the capacity. If the current size of the cache is equal to, you can technically greater than or equal to 2, but the cache size will never be greater than the capacity, or else something is wrong. If it's equal to capacity, we need to kick out the least recently used item. And remember how our least recently used item, it's in the back of the list. And also we need to do you pop back. But there's a trick about cache. No, I mean not cache. On order map, you can delete the element inside. So you could delete this, one of this, by giving it the key. So before we actually pop back, which means we delete it from the end of our list, we should erase it from the cache first by giving it the element in the back of the list by calling back, since this will give us the key, least recently used key, and then we can delete that key from our list. And then after we do that, we need to push our new key into the, actually I don't know the ordering, but I think you do this afterwards, but I'm gonna do it here. You should push the key to the front of the list because this new pair we're gonna insert is gonna be the most recently used. So that also means that we need to update the value to the new one and list to the new one, but that's not too hard because what you can do is we're gonna cache, insert, and we're gonna do the same thing we did. So this is a pair, and insert the key. And we're gonna have another pair of value in the key iterator. Remember how we were to push the, actually, yes, you should do this before the insert, because now since we pushed the key to the front of the list, we know the new key iterator is going to be at the front of the list. So just do begin, and then, and that should be it. When we put on the code, but for your own purpose, you should always test your code. So what I'm gonna do is actually I'm gonna run my main, declare LRU Cache. Cache equals new cache. Gonna give a capacity of 2. And alright, I'm sorry, this is a bit pointer. So now I'm gonna call set 1 and 1. So let's keep track of this. So here we'll have like 1 in the cache, then cache set 2 2. Oh, sorry, I should dereference this. So now it'll be 2 2, and if we do something like cache get 2, to return us a 2. So let's just double check that using center up. Oh, okay. Sorry, I didn't include IO stream. Let's check our work. So out goes cache get. So this should be 2. And then, so if we set 3 to 1 here, right? What we should get now is we should have, since 2, actually let's get 1 1. So since 1 is the most recent access, we should kick out the 2 and replace it with 3 equals. Actually, just the 3. And then cache get 2 should give us, should be -1 because it's not going to get us anything. So our expected output should be something like this: 1 and -1. And let's confirm. Oh, let me see what happened. Will the system pause? Right, so we can stop and see what happens. Oh hey, and look, we have 1 1, which is what we expected. Cool. And I will highly encourage you guys to write some more tests, but since I'm not like going to teach you guys how to write tests and like test for you guys, so let's just try to actually see if it works. Oh hey, look, we got accepted, guys. Alright, I hope you guys enjoyed this video and I hope it was helpful. And yeah, and I'll be hopefully doing more of these videos for you guys. It's a good learning experience for me. And yeah, see ya.